Hi, my name is Sam Walker from the Animal Genetics and Breeding Unit. As part of our videos on helping you better understand your analysis, I would like to expand upon the importance of understanding the relationship between traits in a multi-trait analysis. As we know, when we look at our sheep or cattle, we can often see traits or phenotypes that are related. One of the most obvious is the relationship between the height or the frame of the animal and weight, in that as animals get bigger and taller, they tend to become heavier. However, as with a single trait, we also observe variation in how animals express that relationship, in that animals can be lighter or heavier than expected for their height. But at a population level, we expect taller, larger framed animals to be heavier. Within the genetic evaluation, we use correlations to quantify these relationships between traits. Correlations are a measure of the strength of the relationship between the traits, and they can be weak or strong. Correlations can also be positive, where both traits increase together, or negative, where increasing one trait aligns with a decline in the second trait. A genetic correlation refers to the genetic relationship between traits. A strong genetic correlation suggests that there is a significant number of genes in common between the traits. This would mean if you are to select on one of these traits, you are going to see a response in the second trait. An example of this is early growth traits and mature size. Whereas a weak genetic correlation would suggest that there is very little genes in common between these traits, and it is unlikely that you observe a change in the second trait if you select on the first, as you are not targeting the genes associated with the second trait. An example of this is, say, reproduction and eating quality. Much like using information from relatives to describe the genetic merit of the individuals, we can use the performance of an individual for one trait to understand their performance in another trait. We can do this by using a multi-trait analysis, where the relationships between all the traits are taken into account when calculating the breeding values. Understanding the correlation between traits is highly important within the genetic evaluation and allows us to understand the genetic merit of individuals for traits which can be expensive, hard to measure, or only expressed in one sex. Moderate to strong favourable genetic correlations between ultrasound measures of muscle and fat dimensions on the live animal and their corresponding measurement on the carcass mean that we can get accurate estimates of an animal's genetic merit for carcass traits without having to slaughter the animal. Consequently, we can have genetic gains in carcass composition without needing to slaughter our selection candidates. While some relationships can be favourable, there can be unfavourable relationships. One of the strongest genetic correlations is the correlation between young animal weight, e.g. post-weaning weight, and mature or adult weight. As we observe selection for increasing growth, we also see a resultant increase in mature weight. In a multi-trait analysis, the breeding values take into account information from all the related traits. Consequently, if you only provide information on young animal measures for weight, all the genetic variation observed in adult weight will be associated with that observed in the young animal weights. However, if you record both traits, you can identify animals that break the relationships observed in the population. As in, we can select for fast-growing young animals but have a lower adult weight given their growth rates. As just highlighted, the genetic evaluations behind sheep genetics and breed plan utilise a multi-trait model. Breeding values calculated via a multi-trait analysis account for the relationship between traits, which means that you don't need to think about trait relationships when assessing breeding values on bulls or rams, as the analysis has already done this for you. E.g., if you want growth, select for growth, as the breeding value already accounts for the relationship or impact of other traits. However, we must remember that the breeding values are a reflection of the traits being measured by the seed stock breeder. Thus, when buying bulls or rams, you need to make sure that your seed stock supplier is recording the traits important to you, especially if you are aiming to select against the natural relationship between traits. So in conclusion, the multi-trait analysis utilised by both breed plan and sheep genetics evaluations allow us to accurately model the relationship between traits and provide producers with breeding values that are a reflection of the individual's genetic merit for each of these traits.